So here we are going to study one thing, recursion in C. So it is actually extension to the function. It is also a function, but it has some properties. So we already discussed about functions. So just try to recollect the terms what we have studied in function. What is function declaration? What is function body? What is function header? What is function definition? What is formal argument? What is actual arguments? The meaning of return statement, the meaning of void. Try to recollect all those things. So recursion in C. C language provides the ability of a function to call itself. A recursive function is one that calls itself directly or indirectly to solve a smaller version of its task until a final call which does not require a self-call. So it is a very interesting one. Suppose I have some function called void fun. Have some statements. So inside that I am again writing fun. You all know this is a function call. This is a function call. Where that function call is written? Function call is written in the fun itself. That means I am calling the same function. I am calling the same function. C language provides the ability of a function to call itself. Fun is calling itself. A recursive function is one that calls itself directly or indirectly to solve a smaller version of its task until a final call which does not require a self-call. So the second part of this point will be cleared later. This is called recursion, and such a function is said to be recursive if the statement within the body of a function call is the same function. So this is the body of the function. So in the body of the function, the same function call is there. It is also known as circular definition. Recursion is a programming technique for defining a problem in terms of one or more smaller version of same problem. These things will be clear when we see the next example. Base case or anchor condition, an instance of a problem solution which requires no further recursive call, is known as base case. So these points will be explained with the help of another example. Suppose I have a function to find factorial of n. Fact of n equal to n star fact of n minus 1. So what's the meaning? We all know what is 5 factorial. 5 factorial equal to 4 into 2 into 4 into 3 into 2 into 1. What is 3 into 2 into 1? We all know it is 3 factorial. 1 minute, I made a mistake.
5 into 4, no, sir.
Yeah, I missed 5. 5 into 4 into 3 into 2 into 1. This is 5 factorial. So here 4 into 3 into 2 into 1 is 4 factorial. That means other meaning is 5 into 4 factorial. So 5 factorial equal to 5 into 4 factorial. Similarly, n factorial equal to n into n minus 1 factorial. N minus 1 factorial. Same thing. So here instead of n factorial, I have written factor of n. Here I have written it as factor of n minus 1. These two things you can relate to C functions. C functions. So what happens when n equal to 0? Anyone? Filsa, Kareem?
Yes, sir.
What is factorial of 0?
1.
1. So this condition will happen only when the value of n is greater than 0. So when n equal to 0, we know fact of n is 1. So a recursive function is one that calls itself directly or indirectly to solve a smaller version of its task. Here in the left hand side it is fact of n, but in the right hand side I have got a smaller version of fact, because here it is, if it is fact of 5, here it is fact of 4. So fact of 4 is a smaller version. That's the meaning of the second point. We already discussed. Okay, a smaller version of a task until a final call which does not require a self call. So after some point, this fact of n minus 1 will call n minus 1 into fact of n minus 2. That n minus 2, n minus 3, n minus 4, n minus 5, at some point it becomes n minus n. N minus n means 0. So for 0, we directly know the answer. It is 1. For 0, we directly knows the answer. So to solve a smaller version of a task until a final call which does not require a self call. So here there is no self call. Here we directly write the answer as 1. Okay, coming back to the base condition, an instance of a program solution which requires no further recursive call is known as base case. So here in factorial of n, the base case is n equal to 0. So when n equal to 0, we already know the result, factorial of 1. So that condition is called base case. So factorial means calling the function itself, and it had every recursive function will have a base case or an anchor condition which gives the direct result. So any doubt in recursion, any doubt in these points? Please respond. If it is clear, please type clear in the chat box. So it will be clear when we discuss the example, and we will do the same program to find factorial of a number. Okay. So this is just a mathematical thing. Just keep that in mind, and we will try to map it in the C program. So only thing you have to keep in mind is recursion means function calling itself. Function calling itself, and it will have a base condition also. Varsha, Shibu,
Yes, sir.
do you have any doubt in these things?
No. No, sir.
So what is the base condition? Varsha, what is a base condition? Okay, what do you mean by recursion?
Recursion of calling the function.
Calling the function?
Self-calling.
Okay. So then what is base condition?
No recursion needed.
So when we find factorial of n, what is the base condition? When we find factorial of a number, what is the base condition?
Factorial of 0
Factorial of 0 is
equal to 1.
equal to 1. Okay. So I am moving to example programs. 3 simple examples we will do. Fact rec.c, because it is I am doing factorial using recursion. So this is the function declaration. Meaning is name of the function is fact. Return type is integer. That means the output is also an integer, and the value we are passing or the input to the factorial is also integer. Shan Muhammad. Shan Muhammad, can you hear me? Munna Mishan PK.
Yes, sir. Hello, sir.
Hello. What about the function definition?
Function definition.
Function definition will contain 2 parts, function header and function body. First you say the function header.
Sir, in the main.
Function header, I am asking about function header. Function header for factorial. Anjana, yes.
Yes, sir.
So what is the function header for finding factorial?
In fact,
Okay, in fact.
then bracket in
Okay. Int
n
Indian. Okay.
number.
Okay. Okay, listen carefully. So if n equal to 0, sorry. Advait.
Yes, sir.
So if n equal to 0, what is the value which has to be returned?
N equal to 0, 1.
Okay, okay, it is what? So just write return 1. Else. For easier understanding, I will write it f of n equal to n into f of n minus 1. Condition n greater than 0. F of n equal to 1 if n equal to 0. So this is the base condition. When n equals 0, we directly know the answer. Directly know the answer as n. So else, I am writing return n star fact of n minus 1. So this is the function definition. So I will explain with the help of a small example. Suppose fact of 3. So n value will be 3. N equal to 0 is false. So this statement will not execute. It will execute this statement. Return n star factor of n minus 1. What is n? It is 3. 3 star. What is factor of n? What is n minus 1? N minus 1 is 2. 3 star factor of 2. Again a function call happens. Factor of 2. What is factor of 2? N equal to 0. This is false because n is 2. Now n is 2. It will return n star factor of n minus 1. So 2 star factor of 1. Factor of 1. Same function is called. N becomes 1. If n equal to 0, n is 1. So this condition is false. It will execute this statement. It will execute 1 star factor of 0. So what is factor of 0? So here this one becomes 0. N equal to 0, return 1. So here I have a direct answer, 1. Now we listen carefully. Here, how 1 is generated? How 1 is generated? 1 is generated from the call factor of 0. 1 is generated from factor of 0. So this factor of 0 will be replaced by 1. So here I have 1 star 1. So who called that one? This factor of 1, based on this call only I have written this statement. So this factor of, instead of this factor of 1, it becomes 1. So now I got 2 star 1. So how I got that 2 star 1? By the function called factor of 2. So this factor of 2 will be replaced by 2. Then factor of 3. 3 star 2, that is 6. Last I will get the value as 6. Factor of 3 as 6. So I hope you understood the working of recursion. Is it clear? If it is clear, please type clear in the chat box. So again I am repeating. If you have any doubt, please clarify now itself. Even if you have any silly doubts, you may think it's a silly doubt, but it may be a doubt to a lot of people. I know still people having doubt, they are not asking. So please respond. So those who are clear with this program, please type clear in the chat box. Okay, now I have to write the main function. Main int n printf enter value of n scanf percentage d comma ampersand n printf factorial equal to percentage d. So I am declaring one more variable called f. So remaining part is same as the earlier example. We already discussed about factorial. F equal to fact of n. So percentage d comma f. So earlier I discussed about factorial of 3. So here n value will be 3. Here the call will be made. Initial call of fact of 0. Fact of 3 will be made. So initially this n will get a value 3. Then the recursion will happen. So always remember, so this fact of 3 is called from here. Okay, this will call 3 star fact of 2. This will make 2 star fact of 1. This will make 1 star fact of 0. This fact of 0, I know the direct answer, it will be 1. So 1 star 1. So this fact of 0 it will be 1. This fact of 1 will be 1. Fact of 2 will be this 2 star 1. So it is 2. This fact of 3 will be 3 star 2. That is 6. So finally that 6 will come here and stored in F, and that will be printed. So let me check the input. Some error. Missed the semicolon here. Three. Factorial 6. It will be 720. Okay. Any doubt in this program? Any statements you have doubt, please ask. If it is clear, I will move to the next problem. The next problem is find nth Fibonacci number. Nth Fibonacci number. So you already studied Fibonacci series. 0, 1, 2, sorry, 1, 1, 2, 3. So if I give 4 means it will print 2 because 2 is the fourth Fibonacci number. If I give input as 5, if I give input 5, then it will print 3 because it is the fifth Fibonacci number. So here the input, here I will have to give an input and I will get an output. So if I give input 4, I will get output as 3. If I give input 4, I will get output as 2. So if I give one integer, I will get output as one integer. So you can think about the return type and parameters. If I give 5, it will return output 3. So here I am not generating the Fibonacci series. I am just trying to find the nth Fibonacci term. So if it is 1 means 0, if it is 2 means 1. If the input is 3, the output will be 1. If the input is 4, the output will be 2. So first I will write the formal recursive call. Fib of n equal to Varada. So what is fib of n? How can we write fib of n?
And
It is not clear. What is that?
hello,
Hello? What is fib
hello.
of n? Tell Varada.
N എന്ന് പറയുമ്പോൾ ഈ എക്സാമ്പിളിലല്ലേ?
No, I am asking about generalizing things. What is nth Fibonacci term? So 1 minute. For clarity, I will 1 minute. So this 0 is fib of 1. So for understanding, I am only writing 1, f of f, only writing f. So this f, it is f of 2. This is f of 3. This is f of 4. This is f of 5. Varada?
Yes, sir.
Okay. So how I got this 3, value 3?
3 എന്ന് പറയുന്നത് നമ്മൾ മുന്നത്തെ നമ്പർ ആഡ് ചെയ്യും.
Okay. So we are adding two numbers, previous two numbers. This 1 and this 2. So 3 means f of 5. So how can I write f of 5?
F of 4 plus F of 3.
F of 3. So how can I write f of n?
F of n minus 1 plus F of n minus 1.
n minus 2. Okay, correct. So similarly, what is fib of n? Fib of n equal to fib of n minus 1 plus fib of n minus 2. So that is the recurrence relationship. That is the recurrence relationship. So what are the base conditions? Here I have two base conditions because I know the values of first two terms. F of 1 equal to 0. This base condition I know. Similarly, f of, here f means fib, f of 2 equal to 1. So these are the base condition. So listen carefully. So I am declaring a function int fib because here I am only finding nth Fibonacci number. So if I give n, some value will be returned. So fib int, again function definition, int fib int n if n equal to 1. Sham Santosh. Sham.
Yes, sir.
So if n equal to 1, what's the value I have to return?
0.
0. Good. Return 0. Then I have to check one more condition. Else if n equal to 2. Rahul Bharadwaj.
Yes, sir.
If n equal to 2, what's the value I have to return?
1, sir.
Return 1. Else means anything other than 1 and 2. That means greater than 2. Return. Nuja MB.
Yes, sir.
What I have to write here? Return.
n minus 1.
Not n minus 1. Here I have to make a recursive call. So return fib of n minus 1 plus fib of n minus 2. So here also it is a recursive call because here this fib of n minus 1 and fib of n minus 2 are function call. What is that function? That function is itself. So it is calling itself. Okay. So that function is finished. So if you can write the recurrence relation, you can write the relation like this, it is very easy to convert to the program. Here we know if n equal to 1 it is 0. So just write n equal to 1 0. If n equal to return 1. Otherwise you just write this statement fib of n minus 1 plus fib of n minus 2. So main int n printf enter value of n scanf percentage d comma ampersand n printf term is writing percentage d. I'm making a function call itself inside the printf. So comma fib of n. So I'm giving 5. So I got a wrong output. So no, I got the correct output. Nth Fibonacci term is 3. 1, 2, 3, 4, 5. Fifth term is 3. So let me check on more input. So we will check for 1. Nth Fibonacci term is 0. Here n is 1. So first term is 0. 2. Nth Fibonacci term is 1. Because we all know second Fibonacci term is also 1. So I am giving something seventh term. Seventh term will be 8. So because sixth term will be 5, seventh term will be 3 plus 5, that is 8. Is it clear? Any doubt in this one? If it is clear, please type clear in the chat box. One more example is there that we will discuss later. So any doubts in the topics what we have discussed today? So that's all I want to discuss today. Thank you.